Now the recording. Great. So we'll be quite some people in the workshop. So we'll ask to have all your microphone mutes when you don't have to speak and to use the chat for the question. We will address all the questions directly in the at the end of each presentation if there are some immediate question on them, or also during the interactive parts. Then we will be able to share the slides after the workshop. Now I will just give you an overview of the agenda. So you'll be able to enjoy a lot of different presentations. So the aim was really during this PTA workshop for the audience to get some really concrete insights of how to make the best use of Galileo and Copernicus to ease transport operation. So for this, we will first have an introduction to the JULIA project by the coordinators from Factual. Then we will have an overview of the different application from the technical partner of the project. So there will be Init, NEMI, Geonumerics, and Earthpulse presenting the different application. Then we will have an overview of the concrete use cases. So here we will have the direct PTOs who are working on the projects. For the Catalan region, we will have FGC with Carles presenting. In Slovenia, we'll have Arriva. And for Greece, it will be our partners from THIRST, the research center. Then we will go on with a small interactive workshop just to gather some insights from the audience on your current use of satellite technology, or what do you expect from them, and also what is really of interest for you in terms of JULIA applications. And then we will finish by a presentation of the open call for PTA and PTOs. That is a funding opportunity that is running until the end of April. So without further ado, I will give the floor already to Laura Hashimi, Dr. Laura Hashimi from Factual, to present us the JULIA projects. Please, floor is yours.
Thank you so much, Sybil. Good afternoon, everyone. Welcome to this workshop. I will give a really short intro to JULIA and what we do, and then we'll open up the floor for other speakers to deep dive into different applications and use cases. So next slide, please. JULIA is an EU-funded project under the Horizon Europe program, which seeks to integrate EU space services and data into the public transport sector. It specifically actually focuses on Galileo, the European Global Navigation Satellite System, but you will see that we also have some applications using Copernicus data. Our project aims to enhance the reliability, efficiency, and sustainability of public transport networks, covering buses, trains, and bicycles. And JULIA takes a holistic approach, with its ultimate aim being the development of advanced transit tech, which is the platform we are developing that aims to serve the public transport operators for a better service. Next. JULIA stands for Joint Development for Urban Resilience, connecting users to public transport through space technology. As I was saying, it is funded under a call coming from Horizon. It's an innovation action. We are 14 partners from 5 countries. The project is coordinated by Factual, and the agency that we receive funding from is EUSPA, European Union Agency for Space Program. Next slide. Few of objectives of JULIA. First, it wants to demonstrate eGNSS differentiators as enhancers of the long lead time global public transport downstream market. Second objective is to leverage Copernicus data for climate action and urban mobility innovation. And the third objective of the project is to support decision-making and foster thought leadership aimed at eGNSS and Copernicus investment and uptake in public transport. That's a short brief about the project. These are the partners involved in the project. I was just saying we are 14 partners. You see, we have got a lot of diversity from different European countries. And now the partners will have the say on what is their role and which technologies they have developed, but also the use cases we have in the project. Giving back the floor to you, Sybil.
Great, thanks a lot. If there are any immediate questions, don't hesitate to ask them in the chats, and we'll take them when relevant. Otherwise, we'll do it during the interactive session. So now I'll leave the floor to the technical partner of the project to showcase the different application. So it's also the application that would be directly tested during the open call. So over to you.
Yes, so I can continue on the topic of the application. So hello everyone, my name is Jochen Wendel from Init. We're an IT system provider based in Germany, and together with the partners here in Julia, we developed certain hardware features which we test in Julia, and the applications where these come into place could be the following. So the first one is precise locationing for DRT operations. Later on, there will be a more deep dive into this topic by Nemi. But what we've done in the project application there is the integration of Galileo HAS and OSMNA. So HAS is the hierarchy service, which gives you sub-meter positioning accuracy, and OSMA is an authentication service for the positioning data receiving from the satellite. So the potential use case there we see in DRT operations is the improved matchmaking and the DRT stop location for virtual and dynamic spots. So if you have stops in the inner city or where there's a lot of satellite cover, lacking satellite coverage, this is quite helpful to have precise locationing that you know on which side of the street you're picking up your customers, or where the virtual bus stops are placed. And of course, by precise positioning, we can also give enhanced on-demand passenger information. So you get better ETA estimates for the arrival times and pickup times. And last but not least, the improved route planning to efficiently serve all your customers in the service area. On the next slide, if we go to the next application, where we see quite a huge potential, is the testing of this high accuracy service and the OSMNA service for precise vehicle positioning. And this really comes into play if you have if you want to locate vehicles on larger stops, where you have this bus bunching phenomena occurring, where multiple buses are aligned or queuing up on the bus stop, and you want to give the correct ordering of the bus in the CAT AVL system, the ITCS, or also for passenger information that the passenger knows which bus is currently arriving or in front of the stop, because oftentimes in larger bus stops you have this issue of mixing up vehicles in the ordering process, but also for passenger information. And then the positioning of the vehicle in the network is another use case we see. For example, for bus operations is lane detection and stop positioning. So lane detection would be very interesting if you want to test something with signal light priorities. You want to detect on which lane the bus is moving on to basically prioritize traffic light, give priority to the traffic public transport vehicle for traffic light operations, and also for stop positioning. If you have multiple stops close by, on which side of the road the stop is located. And then if we move on the rail operations, so there we see quite an interesting use case for tram operations for infrastructure detection. So there are several use cases where you use basically hardware beacons on the infrastructure to detect if a tram or a train vehicle is passing a switch. With this enhanced positioning with HAS and OSMA, plus some sensor fusion, we can also do this or test this on a software side to detect a switch, if a switch is passed or not, and also to detect the rail vehicle on the right track side. So this is quite important, not from a safety operational point. This is of course important, but we're not touching this here. It's more for the AVL, CAT AVL and ITCS system, and then later on for passenger information that we always know on which side the tram is located, and also if a tram is changing the track via a switch. On the next slide is the precise positioning using Galileo HAS services for example, for depot management. So this is quite important if you operate depots with larger fleets outside. So of course, inside this won't work because we're using global satellite system. But positioning outside is quite important. You want to know where the bus is located. And then in conjunction with e-mobility, this is quite important for charging management. Also, if you want to implement functions for automatic positioning the vehicle to the charging port, basically. And then also for maintenance to give accurate mileages, but also for the bus ordering on the bus for cleaning purposes, for maintenance and so on. And last but not least, the ticketing applications are also quite important, and there the use case for OSMA comes into quite handy if you want to implement something hands-free, like true BIBO, like be in, be out systems, where the user does not have to interact with the device. We could use geo-positioning and this OSMA authentication to basically authenticate the position of the passenger, and that the passenger actually took this trip for fare management in the end. So it is quite important. Could be very, very, very interesting to test the OSMA feature for these ticketing applications. And if I move to the next slide, there is the DRT pickup, which I will hand over to Nemi.
Thank you, Johan. Yes, as he has said before, I'm going to be going a little bit deep on this aspect. So the application reads effective DRT pickup process enhanced by Galileo, and more specific, functional testing of effective virtual or physical stops geocalization for flexible pickup. This is related because DRT often has some challenges regarding the localization pickup, mostly when we are talking about door-to-door services. Basically because of the precision of the user and the driver, geolocalization is essential. And well, actually, this challenge is more important in dense urban areas where tall buildings and two-way streets or roads can make geopositioning and the whole service less efficient. Some potential use cases also in this application could be this door-to-door paratransit mobility, digitalized school bus route, flexible rural transport, or commuting. But also we are completely open to another potential use cases, and the whole of them will be supported by the NEMI platform, basically for the terms of making a reservation and the position of the geoposition of the driver.
So now we come to the hardware installation process. And before I go into the details about the installation, I would hand it over to Geonumerics to give a quick overview about the HAS implementation side. I see Guillaume is connected, right? You're connected, I see, but cannot hear you.
But can you hear me to the microphone?
Yes, now I can hear you.
Oh, okay. Perfect. Okay, sorry for this short delay. I was having some technical issues to get into the call and to connect all my devices. And and thank you, Jochen, for introducing the first use cases. Yes, as Jochen is saying, we Geonumerics are the technical partner responsible of the implementation of the HAS solution. So we are, as I say, responsible of deploying this service, which contributes to getting a position which can reach sub-meter accuracy. For that, our software Nexa, which is responsible for the geopositioning with high augmented with has corrections, is incorporated in its device, and yeah, it operates in parallel within its functionalities and with the decoding of the OSNMA messages for the navigation authentication.
Yeah, thank you. Yeah. So for the installation part, together with geonumerics, as Guillaume already mentioned, we designed a simple to use setup in Julia, where there's no need for a permanent installation of our solution. So we designed a mounting plate consisting of our onboard unit, the new GNSS receiver from u-blox, plus the antenna and the Nexa software package included in our from geonumerics included in our onboard unit. And as I mentioned, there's no need for drilling holes or no need for permanent installation. We will provide the setup with open-end cables, so your technicians can simply connect that to the vehicle. And all we need is basically power and connection to the ignition for the starting and powering off of our units too. So it's quite simple process. And the unit runs between 8 and 36 volts using 12 watts. Yes, and I saw this message here, if this is compatible. So all our hardware we're using here has train and bus certifications. So we can fulfill with this setup all the requirements for road and rail operations. So our Copilot has certification, the antenna has certification, and I'm pretty sure I have to double check the GNSS receiver which we're using is an eval kit should have this too, but I can double check. But besides this, we have full certification. Yes, on the other slide, if you move to the next slide. Yes, as I mentioned, we designed it in a way that there's no need for permanent installation. So we're not touching any system at all in the bus besides the power. So there's no interaction to the operational system on your side. We have set up a separate backend server MQTT broker where we're collecting the data. We can analyze the data. And for the installation, as I mentioned, we designed this mounting plate. And this can be placed in any compartment where there's space. There are some examples of where we put this in a train, in buses. Yes, the only requirement what we have is we can't put the antenna on the outside. We will have so the position of the mounting plate has to be on a non-obstructed location. So no metal roofing or casing. This usually works very well in trains. They have a carbon fiber or a plastic roof cover on top of the cabin or of the driver, and also in most of the buses. So there's really no issue for us in receiving GNSS signal. We tested this in several vehicles. And all we need is an open-end cables and power to and connection to the ignition. And the devices will have to be installed or mounted by your technical personnel. But then as SIM cards are installed, we can remotely monitor and get the devices to run. There's no issue. And we tested this on several buses and rail vehicles, and the installation is quite simple. It should not take more than 1 hour maximum. Half an hour is more than sufficient because we just place it. If you find the spot, we can zip tie it there, and it's quite secure there, and there's no issue with any systems in operation. On the next slide, here's the general process. So if you select it for testing, we will provide the Julia hardware and it will be shipped to your location. The installation of the Julia hardware will be done by your technicians, but documentation and remote support will be supplied by us. So during the installation process, we can have a video call or we can answer any questions. And also the device to start up and test everything can be done remotely as we have data connection. And the commission and maintenance is done by us because we can do this remotely. And if a failure occurs, we can of course send you a replacement there. The evaluation of the data will be also done by the JULIA partners, as we have an own backend system where we can analyze the data, and this will be done by the JULIA partners. And then in the end, we will return the hardware back to us by shipping it back to the responsible partners. So this is the overall installation process of our systems. And on the next slide, you see some installations, what we have done. So we have installed it on a diesel train, on a regular city bus, was an Isuzu City Link, I think, then on a Stadler train and DRT vehicle in a Mercedes-Benz Sprinter bus. So we've tested it on different sizes, on different wheel vehicles, and on different locations on how to install it. And with this antenna we choose, and we get quite good signals, even if you're placing the antenna in a non-optimal environment inside the bus. But we don't want to drill holes in vehicles, so that's why we're placing it in an area where we still have a usually good signal coverage, and it works quite well in these use cases so far. If you go to the next slide, I would then hand it over to the Copernicus-based data testing.
I'm just checking if they are in the call. I'm not so sure that Fran was finally able to make it. But I don't know if anybody from Factual would like to jump in to explain this part, maybe Manuel or Laura.
Hello. Yes, maybe I can take the lead on this one. So these are two applications that rely on Copernicus Earth observation data. So we have two of these applications, and they are related on one hand to the climate change monitoring, and also any impact that environmental effects can have on public transport operations. So what ArcPulse has developed is an insight repository that enables cities, and in this case PTOs, to check levels of, for example, pollution, and also it gives you concrete insights on what actions you could take as a public transport operator or administration to incentivize the use of public transport, or to reduce even the usage of car dependency when a certain environmental effect can take place. This repository is already available on the JULIA project website, and we will be tailoring it to the specific pilot that you'll be applying to. So you'll have access to this dashboard that will contain insights on air quality, climate change, and other environmental factors that could affect public transport operations. And here we have some images of the dashboard that I was referring to. As you can see, it's possible to monitor air quality using historical and forecasted pollutant data, climate change, more in the long-term assessment, weather, temperature, and rainfall indicators, and this can help you benchmark your cities to others and plan resilient services. And finally, weather forecasts, these more short and mid-term forecasts for temperature and rainfall, also enabling you to anticipate any potential operational disruptions, especially in such extreme weather events that we've been witnessing in Europe. So I believe this is also a very useful tool for every public transport operator. Yes, and here I believe this is a bit more on the technical side. And yeah, it can be connected via an API, and you can access all this information, weather, air quality, climate, weather data sets, and yes, then you can automate this or create your own custom applications. And definitely there's no need for any hardware installation in this case. And with the location of your city or the operation, they can deploy the system in just a few days. Thank you.
Thanks a lot, Mene, for jumping in. So that was all for the part on the technical aspects of the different application of the JULIA project. And so you see that the first one all using Galileo, and then the one using Copernicus. Is there any immediate question? I don't see any other in the chat. So yeah, if you have any coming, like please just write them. Otherwise, I suggest that we go over already on the pilot parts, so you can see really some super concrete example of how these technologies are used. So the first pilot is our Catalan pilot, and we will focus especially on the rail part. That is for now the most interesting to share with you. So please, Carlos, you can introduce yourself, and then present the rail pilot.
Thank you. Well, I'm Carlos, a member of the innovation team in FGC. We are a public company based in Barcelona. And thanks to Julia, we decided to install the system developed by INIT and by Geonomerics in our rural line that we have from the city of Lleida to the Pyrenees. It's a first overview of the line. It's a line of about 90 kilometers long, but covers basically rural areas, as you can see in the picture. And it's a line that we have only 12 services per day. So it's a low usage of conventional public transport in this area, because basically people use the car to cover this distance. So the main application is the AGNSS-based train positioning system to provide a reliable and efficient solution for railway operations. And also it helps for us to operate this line knowing at all the moment where is the train, which is something that we don't have before. And also to help the people of these areas to know where the train is and to organize better their system. Also in the future, if this system works properly, it allows us to connect with sensors installed during all the line and monitor critical different elements of the rail tracks, and enable to train shutdowns when a relevant alert is raised. Next, please. So here on the 16th of December at night, we were installing the equipment in our train in the upper part of the machinist cabin, because it was the easiest one that the antenna is can see all the sky. We install it in two of the three trains that we have on the line, and now it's running with the system installed, and we are receiving, thanks to INIT and Geonomerics, all the information regarding the geopositioning of the train. The test is planned to take around 6 months in a first step with both equipments. In May, more or less, we will install the equipment of Geonomerics, and then some months after, we uninstall also the equipment of INIT and conclude of the test.
Thanks a lot, Carlos. So yeah, out of the different the help that it goes for the geolocation, do you think it could be useful and easily reused on other train lines, or do you think there are some specification of the train lines that should be taken into consideration before implementing such technologies?
Well, usually the main conventional lines, the ones that have a high demand, are nowadays really well connected, and you used to know where the train is thanks to the communication systems that are installed. But for more rural lines or with less demand, like this one that we have, the implementation of these communication systems to control the operations of the train, if you have to implement the conventional elements, is really expensive. And having a system like the one developed in Julia, it helps us to take the control of the operation, and for a really cheap price also. And it's really convenient also for a line like this one that goes across different mountains and hills. So it's difficult to implement this kind of systems.
Okay, thanks a lot. Then we'll move on to the Greek use case. We can see Joseph connected from Thurs, who could present exactly, the objective of this use case. Floor is yours.
So in this use case, we are having different use cases. This is the one that we are presenting today. We want to assess if the higher accuracy of Galileo, it has an impact on map matching. Map matching, if you know, is the technique to allocate an individual position to a road segment. This is important for many things, like traffic congestion, like routing of vehicles. And from our experience, we know that map matching can have easily up to 30% of misallocation of these individual GNSS locations to the links, especially within cities, especially in intersections, roundabouts, or when you have two levels on the street. So on the next slide. Okay, so there are different techniques. The easy one is geometric, so just find the closest link. But this is, as you can imagine, this is not the best one. Then we had more complex methodologies about topology. So we are following the trajectory within the network, and we can see if this movement was feasible or not. But this has a high computational cost because you are keeping the trajectory and checking for topology rule within the network. And then other techniques, probabilistic, to find the most probable link based on rules, based on the topology. And then AI techniques, again, trying to learn from the data. Of course, here we need to train, we need annotated data sets. So in the next slide, it's what we created. It's an algorithm that it's a combination of the AI approach, but also the rule-based. So we are trying to increase the efficiency of the rule-based solution by adding AI and trying to reduce the needs of the AI on the annotation and on the training. For this, we use taxi vehicles for the training of the algorithm, but in Julia, we will see how it works with bicycles. Because in the taxis, we need to find the taxi within a lane, which can be 2-3 meters of width. But in the bicycles, it's much more difficult because it's about the bike lane, which can be 1 meter. So it's even more challenging to find if the bicycle is inside the bike lane, on the sidewalk, or with the cars. On the next slide. This is our flow. So we have the raw data, we project the data, we transform the data, we apply the technique, and then at the end of the flow, we add the rule and the topology to the data, trying to get the best of every one of the techniques, and to end up on the numbers that you will see on the next slide. Traditional rule-based had a very poor performance, less than half of the locations were good allocated. We combining the transformation and the rule-based, we end up on 76% or 3 out of 4 allocations. Of course, one-way links have a better performance because it's one way, so there is no issues. But then we get into more difficult geometries. Two-way links sometimes they are close to each other, so you don't know if the car is going back. Intersections, especially if you have this deviation on the highway, so you need a little bit of distance to see if you are on the highway or letting the highway. Roundabouts and where there is a great difference. Just the accuracy, it's even in cities, it's up to 69%, which is the area that we are working in Julia. And the paper is published. This is a previous paper where we had the methodology for taxis, and now we are adapting it to the bicycles and to the bike lanes with the improved accuracy of HAS from EUSPA. So in the last slide, this is our use case. We are having an OPU on a bike, which is circulating on the
Great.
bike lane.
Josep, just before
Yeah.
maybe the concrete use case, there is a question in the chat that is directly related to the previous slides. Emmanuel asking what was or were the base maps used for the map matching?
Yes, depending on the shape file that you are using to map match, you will have a different result. In our case, we are using OSM, so we can map match the data to OSM. But I think that different operators may be using different geometries for the network shape file. So what we're doing in Thessaloniki, but of course you can do another use of the map matching. We are checking how having an OBU on a bicycle, which is not as easy as it seems. We need a backpack, we need a battery, but we want to do the proof of concept of this possibility. We are taking a video of the whole route. So then offline we can see the video, we can see the data, we can have the data improved accuracy, improved accuracy. Apply the map matching compared to the ground truth, which is the video, and then to see what is the added value of HAS and other services to these map matching results. Of course, you can make use of the algorithm for a different use case, not the bicycles, but this is how we are going because you can see how narrow is the bike lane, so we really need high accuracy to find out the bicycles on the bike lane. Why we want to do this? This is because of enforcing, because of understanding if the people is driving within the bike lane or on the sidewalk, because then different speed limits apply. Yes, I think that you can use any background map because the methodology is having a GIS file and a cloud of points to be map matched. So any GIS file you use, it will work, of course. So that's Thessaloniki.
Thanks a lot, Josep. Emmanuel, is it okay for you to have any additional question? Because we may not come back to this precise topic after, so if you have still any question, you can ask them now or pursue the conversation in the chat. No issue for this.
Yes, yes, thanks for the answer. What is interesting with over two maps is the base map and as well what is called a global entity reference system, which is giving a unique ID for any geospatial entity. So that could be relevant as well to check if using this will be improving the methodology or not. I will put the reference in the chat. Thank you.
Yes, thank you, Manuel.
Thanks a lot. So I guess we'll move to the Slovenian pilot, and I leave the floor to Ishtak from Arriva Slovenia.
Yes, hello everyone, and welcome to Julia, also from the Slovenian team of it. I will be frank, okay? We didn't join the pilot for such great scientific reasons that our colleagues have explained, but we just joined basically the project in itself to test it and to see how the communities we serve could benefit from the service. So we are basically addressed, let's say, the project's activities in four levels, in 4 towns, and this is through 2 DRT services. One in Ormož, this is a village in the northeastern, and one in Piran, which is basically the opposite direction, so southwest on the coast of Slovenia. And of course, really what we wanted to address is, for example, in Ormož was how can Galileo or say EGNSS technologies help us in alleviating the needs for mobility in rural areas, in areas which are underserved. And of course, how also we can further replenish the mobility standard. Then for the second pilot, which we will do in Piran, basically we just wanted to test if it's possible to decrease the accessibility gap between, let's say, a seafront touristic center. Imagine, for example, Monaco or let's say the Côte d'Azur and the hinterland. It's hinterland. So of course, an overlooked area sometimes using, of course, Galileo and Copernicus supported technologies. And as already Josep mentioned before, we also assessed the cycling infrastructure safety in the city of Kran, which is also where the head of our operation is. And of course, what we're also looking forward and mostly looking forward is the autonomous vehicle pilot. Well, we will trial it to be the first serious trial in Slovenia, but of course in a closed environment by using really the eGNSS-based positioning tools. Next one, please. And of course, here we have a couple of pictures here. Okay, one thing is the picture of the NEMI app, of course, where with the 3 drawn lines. Okay, because here you can see, okay, you can't see it, but it's a rural area. It's on the border between Slovenia and Croatia. And of course, we are serving 3 lines, 3 sets of towns, where basically we're trying to enable them to access public transport through accessing, let's say, the main hub, the main transport hub, which is basically Ormož bus station, so that they can reach either the center of the municipality or the connecting bus lines, which we operate as part of the regional transport contracts. So these 3 areas, these 3 lines have been defined in terms of, let's say, fixed routes with, of course, with some stations or stops which are on demand. This means, of course, if someone will book them either through the app or through a call center, okay, we will stop there. Of course, the service is running, let's say it's still operational till the end of March. And of course, then also, of course, as a consequence of it, of course, we're also following the analytics through detailed analytics through the back office, and of course, also dashboard presented area. Of course, what we saw is basically this was, let's say, the first service as such, as it was a special service, which is not with a vehicle 1+8, which is usually how most DRT services in Slovenia and widely operate. But of course, it's done with the help of a minibus, where of course as already Jochen from INIT mentioned before, of course, also the INIT hardware, or let's say the plate steel, was also already installed. And of course, then we started. But of course, we needed to get an approval from the ministry, simply because it was a special type of public transport, and it kind of delayed a little bit the start of the service for several months. And of course, thus, of course, also the big bang effect of some advertising publicity, which we're already doing. And of course, due to delayed service, we had to redo all dissemination, simply because it was a new area, simply to get the message out there. So of course, what do we see? We see, of course, that this project will bring, let's say, its offspring will be new DRT projects, regular DRT projects within the area, as we see that already municipalities and neighboring municipalities, not only the municipality of Ormož, are connecting with the purpose, to provide better mobility to its citizens and to tourists, as this is a widely known as a wine-growing region. Next slide. So of course, then what we're moving then to the municipality of Piran, which is also again on the border of the Croatian with the Republic of Croatia, but this is really on the southwestern end of Slovenia. So it's and of course it will run from the pilot will run from May to September this year, when we call it the tourist season peak. What's in it for the municipality? For the municipality and the touristic regions is that, of course, in summertime, during school holidays, the public transport itinerary, the public transport timetable significantly drops. And of course, what we're doing through the pilot, we're offering a 100% on-demand service. So which means if there's no demand, there's no operation, it's not operated. But of course, it is to connect all the towns, all the settlements, which you see in the variations of the green color, with basically the town of Lucia, where they also have then regular urban transport connections to Piran and Porto Roșu. So, of course, we invite you to see the service, to test the service, and of course, also then to see the outskirts or the hinterlands of the Piran municipality. So, of course, the idea is, of course, to provide a better mobility service and connect the tourist hotspots with the cold spots, because usually, everyone knows about Côte d'Azur, maybe, but not so much about the towns behind. So yeah, our Côte d'Azur awaits. And if we can move on to the next one, which is really one of the more exciting. Why? Because of course we're looking, of course, at doing an AV pilot, which is for us a demonstrational breakthrough. We have a chosen vehicle. So this is an Estonian, let's say, startup, Auvitech, with its, let's say, small shuttle Mika 2.0. And of course, this will be done as it can only due to legislation needs. But I would just say, let's say that our legislation is reserved to testing on open roads, as a lot of it in the European Union is. We will test it in the industrial compound of Tanum, which is an aluminum factory, which is spread over 120,000 hectares. And of course, it has its own, let's say, road system, which enables us to provide the transport of employees, of people within, and of course, eventual visitors to the compound, irregardless, of course, of the fact that they have a very well established cycling system within to promote healthy living. For us, of course, because of this, it's the eGNSS and its precision are key to a successful operation. Of course, already also in the fact because the vehicles are autonomous, but also regardless of that the vehicles are autonomous due to legislative demands, we need a safety steward. A safety steward on top, of course, it has to be experienced driver, just in case to take over the operations. So this we're looking to be done between the months of May during the summer or also early fall, starting beginning in May. So this is something which we're very looking forward to provide some feedback, because there was really no testing on AVs so far yet in Slovenia. There was one attempt by Navia in the shopping center, the shopping mall in BTC in Ljubljana, but simply the traffic density and the speeds were just really too heavy. There's too much people, too many interferences for the leaders. So yeah, and this is what we're looking forward. So we're really grateful to be cooperating with all the technical partners and with all other partners within this project, and to make a breakthrough in cases like this, because also cases like this will help us in the future to build or to prepare our mobility suite for the new services. I see there's a question in the chat. And looking at the testing, can applicants to this call propose a testing pilot of another kind, self-driving, or does it need to be an already existing running service?
I think that's a question directly for the open call parts. I don't know if there is an immediate answer from Ethico or from Factual on this. Or we can come back to it when we present the call if you prefer.
And as for the other question, we didn't test, let's say, in our use cases, indoor positioning. Okay, this which can come handy, of course, if you do in some underground terminals and stuff like that. Yeah.
Yes, Emmanuel, do you want to discuss it now with this Umlux technology?
Yeah. So Umlock is similar to OGC open specification for outside, I would say. And that's super interesting for indoor, inside. And as some vehicles could be both indoor and outdoor, I was wondering if the test in Slovenia is including indoor, but you replied, Istok, not, or not yet. And yeah, Omlox is an open specification dedicated to indoor. So if anyone, either existing use case or new use case, are willing to combine, you should have a look at this Omlox specification, which is relevant for me, combining both GNSS and indoor positioning.
Okay, thanks a lot for this addition. Any other question maybe on the Slovenian use case? I don't see any more in the chat. So maybe then it would be time to go for this little interactive exercise that we wanted. So we will give you access to the mirror board. So maybe Elisa, if you can add it in the chat, so you can all connect. I will invite especially not the JULIA partners, but our audience of today to join the mirror board. And because we have just some quick question to ask you. So it will revolve under your current use of an awareness of the satellite technologies, the different challenges that you have in your transport operation that you have to face daily, and how it could help to solve them. We'll discuss quickly also the barriers to adoption, what could hinder to use those technologies. And then I will invite you to do a small vote on the different Julia application for you, which one are the most relevant. So I will now share the Miro so we can all check directly. I will share my screen. So I think, yeah, you can see it directly. So I see you're all connected. Great. So I will now just invite you. I don't know if you're all familiar with this kind of tool, but it's really easy to use. You can just click on the different post-its and write directly your input. You can also speak up and just talk directly with the mic. But the aim is like really to gather the input there, so it will be useful for the JULIA partners. You can also put the name of your organization if you on each of the post-its. But yeah, thank you, Florian. So you're already answering the first question. That's perfect. So yeah, indeed, the first question is how familiar are you with Galileo and Copernicus tools and their potential application in public transports? So I know that in the audience we have people from different kind of organization, PTO directly, also consultancy in this in the topic, and I think it's really interesting for the Julia project partners and the European Space Agency as well to understand if you were familiar or not with those technologies. Yeah, and then you can directly answer the second question, which is, are you currently using any Galileo Copernicus-based solution? Really, if you're not familiar with those tools and if you're not using any of the technologies, please also put it. It's also interesting to know really our aim is to assess how those technologies are really well spread in the public transport world. So also you can go on there also then the question on the different challenges. So here it's really we want to understand what are the biggest operational and strategic challenges that you face in public transport that could be addressed by those tools. So you saw that in the presentation, we explain you a bit what were the different challenges that the JULIA partners were facing in the different pilots. So for the accuracy, the geolocation accuracy for the train, how to best handle a DRT system, how to run some pilots with autonomous shuttle, but you may have some other ones that could also be related to those technologies. So please don't hesitate to put them there directly. And in the second part, you see that there are different examples with um, like real-time tracking, route optimization, infrastructure maintenance, and also environmental monitoring. So that would be more on the Copernicus part. Then we have this question on the barriers to adoption. So here, really those kind of tools. There can be some technical barriers. It can be the fundings that are not sufficient. There can be some issue with your internal national regulation hindering you to use those tools. Not having the specific skills to install those tools. And we wanted to understand a bit how we could overcome those barriers. Could it be via trainings, via case studies, having more fundings, being able to run some pilots? So yeah, please feel free to answer. And then you see that the last part is on the Julia application directly. So I'll give you still 3-4 minutes to answer, and then we'll do a short recap before going to the open call explanation part. Yes, Florine, I saw your message in the chat. No problem. If you can connect from your mobile phone, it's perfect. Don't hesitate to put the name of your organization on the post-its so we can understand a bit where it come from. So I see some post-it fields already. Do you still need a bit of time maybe to fill the other one? I see less movement, so I can begin to go through the different post-it. But sorry, I see a question from Emmanuel in the chat. Yeah, so I think I can take it. So the question is Julia already in contact with data sharing initiatives in Europe, such as EONIX and the Mobility Data Space, and the European Mobility Data Space, EMDS? There were not, there are some common partners. Police is part of the two projects, but there were not explicitly some data sharing on this topic. So I would say that the answer is rather no. It followed a bit two separate tracks up to now. So if we go on the first question, so how familiar are you with Galileo and Copernicus tools? So we see two answers, not very familiar. I've heard of it, but not have a deep knowledge of it. It's usually what we hear. That's there is some knowledge about those tools, but not really what they do concretely and how we can make the best use of them. So I don't know if anybody wants to speak up on this, but I think it's rather clear. So here, are you currently using any Galileo or Copernicus based solution? We are using GNSS system for our AVL system. Would you mind taking the mic and explaining a bit more how you use it? If it's okay, I don't know who wrote this post-it. Just to explain in 1 minute how you use it. I don't know who wrote it. Still online or otherwise we go straight to the next question first. So for the operational challenges, so here what mentioned real-time tracking, driver compliance, and reliable real-time information. So for the driver compliance, maybe can somebody speak up and explain exactly what was the issue? Just in 1 minute. I don't know who wrote this. It's interesting because it's not a challenge that was addressed so far by the project.
It could be. I think it could be Florin. I see he's a PTO from Timișoara, so usually.
Okay, Florin, do you hear us?
He left.
Okay. Too bad. It would have been interesting to have a bit more info on this. Then here, in terms of other struggles, so route optimization, only in very rough terrain. Okay, this would need maybe a bit more details. Yeah, to understand exactly what's the Okay, so the struggle, okay. So if I understand right, so there you would need this kind of technologies on this specific landscape and part of the network. So a bit exactly what Carles from UGC was mentioning, that it's in this hilly and mountain areas where the tools were the most useful for the train lines. In terms of barriers, so here we see financial, local expertise, the costs. For Kazan, so I think it's, if I'm not mistaken, it's in Philippines, it's the policy framework. So it means that you're not allowed to use this kind of tool, or you're not allowed to test.
Um,
Yes.
okay. Hi, everyone. I'm Claude from Quezon City. Um,
I'm sorry, we can't hear you so well.
describe it. So
We cannot
we
hear
have
you.
this like local transport known as GPS, and it's actually regulated by the national. It's like a national agency here. But this that I think I'm worried.
I'm sorry, the sound is not so good on our side. I'm writing in the chat. May you write your input in the chat because we think it should be a really relevant one. But maybe if you want to write it, so you can still share it with us. No problem. So we can understand a bit what's the policy issue that you're mentioning. And then, yeah, what could be Okay, no problem. But please just write in the chat if you want, so we can still have your input. And so to overcome those different barriers, so with the of cost of local expertise. So yes, indeed, there would be a need for trainings for the local expertise and the local teams directly. Having example lessons learned from case study would be beneficial. Indeed, it's already a bit what we wanted to do in this workshop, to give you an overview of the local case studies. But they are all running for now because we are in March and the project is finishing at the end of November. So there will be another workshop that should be planned around September or October, where we'll give all the lesson learned from all the pilots, all the different levels of pilot from the JULIA project, and also from the PTO that will test the application in summer. So that's indeed would be, yeah, we really want to do more peer learning between PTOs. What we can see if we go for the different JULIA application and what is the most of most interest for the people in the audience, we see that there are 2 votes on the precision location for DRT operation. So that's one of the key challenge that would like to be addressed, and of the positioning of the vehicle in the network, and also another one on DRT. So it seems that here for our audience, it's really the DRT system that's could be improved thanks to those technologies. Thanks a lot. So if we come back to the issue with policy, I'm going to read what's in the chat. So in the Philippines, so the local transport is mainly the jeepneys, and they are being regulated by a national agency. However, it's the city doing the local public transports, and who wants to determine the jeepney routes with the local jurisdiction. So we are trying to figure out how the technology can help us. So yes, so it means that technology and the location of the jeepney could help go over and give some arguments, I guess, to make sure that to align the jurisdiction and the national and the city level. Okay, that's really interesting. I think it's really not one of the use that was already studied during the project. So that could be really an interesting angle as well. I don't know if there is any other inputs so far. Here, just one other from TPG, so in Geneva, Switzerland. Yes, here it's the automated vehicle that are using Galileo. Great. Thanks a lot. It's already really useful to have your point of view on this. I will turn also this Miro board into a survey that we will share with other PTOs to have a really good overview in the end of the use of those technologies, and which angle can still be exploited and studied. Now I see it's already 3:15, so maybe I will give the floor to Ertico and Apollo Teneci, who is going to present the open call. So you can have a really good overview of how to apply if you're interested to test the JULIA application. So I'll go back to...
Yes, thank you. Good afternoon, everyone. Thank you for being here today with us. My name is Apollo Tineci, and I'm coordinating the open call in the JULIA project from the Ethico ITS Europe point of view. So today I will work through the main objective of our open call. So the idea is who can apply, how to process work, and what you can expect if you will be selected as a PTO to test our equipments. So let's start with our propose of this open call. So the goal of Julia open call is to select 5 PTOs and them to run a real pilot implementation of the Julia application. So this pilot are designed to test the innovative solution in the real environmental insight. So each selected partner PTO will receive a lump sum funding of 15,000 euro, and this funding means that we support the implementation of the pilot in the real in these related activities. Can we move down to the next slide for the timeline? I wanted to talk about the timeline pilot. Yes. So the pilot are expected to start sometimes in July. The pilot will should be run between 4 and 8 weeks, so approximately 1 to 2 months, and everything must be completed until 15th of November 2026. So in terms of deployment and in terms of solution, our colleagues already explained the application. There will be 5 applications, A1 to A5. So basically, the first 3 applications will be hardware-based, and the last 2 will be only software-based application. And now let's look at who can apply. The application basically must be a public transport operator or an organization mandated by the public transport operator. They must be established in a Horizon Europe eligible country, meaning EU member state or associated country. In additional application must be implemented, must be in an independent legal entity, and that means that partner already, so that means it's not someone involved already in the Julia consortium. Very important for us is that the selected PTO have the operational capability to run this test. The applicants must be able to implement the pilot with a given time frame. So the time frame is 1 to 2 months. And the applicants also needs to ensure the compliance, meaning the GDPR. Very important also, we decide to let any applicant to run, if they really want to be able to run also more application than only one. So one applicant can apply for one or two application if they like to. Now, to talk about the timeline. So the open call, we launched this open call 27th of February. We had a webinar held on 13th of March, and today we hosted this workshop. The submission deadline, it will be 30th of April at 5 p.m. set time. And after this, we'll follow the evaluation during the month of May, and the contractual phase will be June or July. So, and sometimes beginning of July, we will start this pilot activity. Now about the how to apply. The process is designed simple and efficient, intentionally to get more applicants to have on board. The applicants are required to complete an official application form provided by us, and to answer typically some question, and they must be the application form must be signed and submitted in the PDF format before the deadline 30th of April. All the application needs to be sent via the mail opencall@juliaproject.eu. In terms of basically, we would encourage that not to send more personal data than just the business contact detail due to GDPR. And now I would like to move forward to the evaluation process of this open call. So we split basically into two steps. The first one, the eligibility check, and this includes the verification of application, if it was submitted on time, if it was signed properly. We will check the applicant country, so if it's coming from eligible country as well. And then so basically after the step A, we say yes or no. If yes, then we move to the step B, where we split the step B into 4 pillars. The use case. So we consider the first pillar, relevance and alignment of the use case. The second, operational feasibility and timeline. Technical capability, and the final need, motivation and clarity. And, based on this, we will attribute points scale from 0 to 5 across these 4 criteria. Now, regarding founding and contracting, the selected transport operator will sign a service contract with Artigo on behalf of Julia Consortium. The founding, as I mentioned, €15,000. That means that at the end of this pilot, based on based on final reporting, so the PTO will receive this payment. Of course, not before for the pilot involving hardware specification, hardware like A1 to A3. After we receive back this hardware equipments provided by the Julia pilot. Finally, a few words about the next step. We will encourage every PTO to apply for this open call. Please have a look on our website, the Julia project, and download all the documentation you need for application. If you have any question, clarification, and so on, you can send them until 15th of April to the mentioned mail address. And we expect your submission by the end of 30 April 2026 at 5 p.m. Czech time. For any communication, the mail is here. For more info, we have the website. And to conclude, this open call will be a good opportunity for the PTOs, public transport operator, with the minimum administrative effort to have the opportunity to test our innovative solution in a real environment. And I thank you very much for your attention and maybe some question to be answered.
Thanks a lot. Thanks a lot, Apollo, for explaining everything about how to apply, who is eligible. So you see here the email if you have any question. I don't see immediate question in the chat. In any case, so the first webinar and this workshop was also quite dense with a lot of info that was shared among us. So I think it's now a bit time to digest. We will send you the slides so you will have access to all the different details about the application, the hardware, how it was installed, how it was directly used by the pilots, so you can read it with calm and also still try to prepare your application. If you have any question before submitting your application, there is still 1 month left. All the Julia partners are available to answer. Please just ask all your questions directly on this email, and it will be redirected to the right person. I don't know if there is any other immediate question. Otherwise, it's nearly time. We are perfectly on time, so it's great. I will now just take the time to thank all my partners from the project for their time and really insightful presentation. Really thanks a lot to everyone, and we don't hesitate to contact us to have more info on the project, on its application, and the technologies. I don't see any more questions in the chat, so I'm going to let you spend the rest of your afternoon, and let's be in touch until the end of April then. Thanks a lot, everyone.
Thank you. Bye-bye.
Bye.
Bye-bye.
Thank you. Bye.
Bye-bye.